So now we discuss tests on the variance and standard deviation of a normal distribution. And from our learning from confidence interval estimation, if we are using sample statistics and estimate the variance and standard deviation, the test statistic that we will be using is chi-squared test. So same here, this is a chi-squared test for the variance and standard deviation. It is a statistical test for a population variance and standard deviation. So the sample statistic is the sample variance and the sample standard deviation, S squared and S. And the standardized statistic is chi-squared. So this is chi-squared equals n minus 1 quantity, n minus 1 times S squared over sigma squared. So that is the formula for chi-squared, for the computed chi-squared. So we have here now an illustrative example for this case. An automated filling machine is used to fill bottles with liquid detergent. A random sample of 20 bottles results in a sample variance of volume of S squared, which is 0.0153. If the variance of volume exceeds 0.01, an acceptable proportion of bottles will be underfilled or overfilled. Is there evidence in the sample data to suggest that the manufacturer has a problem with underfilled or overfilled bottles? Use 0.05 alpha and assume that the fill volume has a normal distribution. So the problem here is that there is actually an automated filling machine and it is filling liquid detergents. And then from there, the researcher sampled 20 bottles, no, and it has from the 20 bottles, the sample variance is 0.0153. Okay, now the statement here is that if the variance exceeds 0.01, again, if it exceeds 0.01, there is an acceptable proportion of the bottles. So it's unacceptable maybe because there is an underfilled or overfilled of liquid detergent. No, it's not the appropriate level of the liquid detergent, no, in the bottle. So the question now is that is there an evidence, no, in the sample data that suggests that the manufacturer has a problem with underfilled or overfilled bottles? So out of the 20 bottles being sampled, does that show that there is an overfilled or underfilled bottles? Using 0.05, we need to conduct an hypothesis, a test of the hypothesis. So step one is we need to identify our null and alternative hypothesis. So in this case, our parameter is not anymore mean. So it's not mu. So thus we will be using the sigma squared. So sigma squared is less than or equal to 0.01. So that's the claimed statement. And then our alternative is that sigma squared is greater than 0.01. It means that there is an underfilling or overfilling of bottles. No, diba, if it exceeds 0.01. So our step two is to choose our level of significance, the type of test, and the sample size. Our level of significance is 0.05. The type of test, because our alpha is, how to use the laser here. Our alternative hypothesis is basically greater than, so our type of test is right-tailed test, and then our sample size is 20. So in order for us to know the critical value of chi-squared, we still need the degrees of freedom. So our degrees of freedom is 20 minus 1, that's n minus 1, which is 19. And then using the table, we can actually look for the value of our chi-squared, which is 30.14 in this case. It's 30.14. Now remember, if it's chi-square, there is no negative value. So if you are to model it, it will look like this. Now there is no negative value, so it starts at 0. to infinity. So there is no negative value for your chi-squared. May it be two-tailed or left-tailed. So both values are positive. So, but same concept, the rejection region is your alpha, and then this is now your distribution model. So compute the chi-squared value. So this is now the standardized test statistic. Chi-squared is equal to n minus 1 times s squared over sigma squared. Your sample size is 20 minus 1. And then our s squared is 0.0153. And then our hypothesized variance value is 0.01. And then calculate them, the value now is 29.07. In this case, it's somewhere here. Okay, it's still in the non-rejection region. So expect that the conclusion for both using the critical value and the p-value is do not reject your null hypothesis. So as a conclusion, at 0.05 level of confidence, there is no strong evidence that the variance of fill volume exceeds 0.01. So there is no strong evidence of the problem with incorrectly filled bottles. So the filling is still good because there is no such thing as overfilling and underfilling, based from the hypothesis test that they conducted. So in our next video, I will be presenting to you another tests, but this time it's tests on population proportion.